Hello, everyone, and welcome to this Dr. Spotfire October session. This is every Tuesday of every month, the first Tuesday of every month. We have the Dr. Spotfire live session, and here on stage we have our hackathon winners from TAF. Do you want to say hi to the audience and present yourself real quick? Atir.
Oh, sorry. Hello, everyone, and then welcome to our monthly session of Dr. Spotfire. Congratulations to all the forerunners. Looking forward to your presentations today.
John.
Hi, I'm John Henderson. I'm Chief Analytics Officer of Intertel.
Luisa.
Hi, I'm Luisa Porras. I'm Subsurface Engineer at Birchcliff Energy.
Okay, Brendan.
Hey everyone, my name is Brayden Gilchrist. I'm a product manager with Inveris.
All right, Thomas.
Hi there, I'm Thomas. I'm an analytics engineer at Birchcliff Energy.
And Lee.
Hey, I'm Lee. I'm supervisor for strat planning and business intelligence with Birchcliff Energy.
Awesome. So, the dynamics of this hackathon is that we're going to go through each of the winners, and we're going to discuss how the challenges, feedback, and experiences doing the hackathon was. So let me start my screen and let's go through some announcements before we kick it off. And so remember that this event is recorded and is live in YouTube, LinkedIn, and other channels like Facebook. It's recorded. You can always refer to the previous recordings on our Dr. Spotfire office hours. And so if you miss this one or previous one, you can always watch it. Keep the questions coming. Remember that the tab, the analytics forum, is still open on demand. You can still register. You can watch the videos on demand. There's great presentations there. I personally recommend Enertel presentation. It was a great presentation. That's one of the ones I like. And there's so many others that you can learn from. The website is theanalyticsforum.com. Just go to theanalyticsforum.com so you can keep watching these sessions. So remember, our motto is learning is not driven by answers, but by questions. So keep the questions coming. That will trigger your curiosity by asking questions, and we will be answering those live. If not, just keep asking, and we will come back to them offline. So today's session, the TAF23, the Typical Analytics Forum Hackathon winners, and it's the stage is yours. Atir, you want to, since you organized the event, maybe you want to talk about it.
Yeah, sure. Let me share my screen. So this year event or this year hackathon was a little bit different from the previous year since it touches people's lives directly. And then what we're trying to do is we're trying to understand the food deserts problem in Houston. And then what we mean by food deserts is having, let's say, resident areas that the nearest access to, let's say, a good source of groceries and food is maybe more than 1 mile. And that will make it very difficult for people, especially like, let's say, poor areas where people don't have access to cars to walk to the grocery stores. We had a lot of discussions even with the Houston Food Bank and local organizations just to understand the problem. And then it seems like there are, let's say, a lot of factors that contribute to the problem, and we try to collect as much as we can of data for the hackers to use. And then this problem also was inspired by a very old problem, which is when the cholera broke in London in 1854. And then there was a physician, his name, surprisingly, John Snow. He used the geoanalytic and then data mapping or like geospatial representation to understand the problem. And then eventually the problem was narrowed down to one of the pumps in the neighborhood that was infected. So this was part of the inspiration also, and then plus Neil brought that problem since he has experienced some of it when he was in Houston. Yeah, and then we decided to keep the challenge open ended. We did not let's say put any set questions because we thought that putting like a definite question will maybe kind of like limit the creativity of the hackers to solve the problem. So, and I think we were right. I'm really impressed with the submissions that we got, and then the different ways that people approached the problem. So, with that, I would like also to congratulate the winners again, and then let's switch to the presentations.
Okay, so how many participants did we have?
So total we have 60 participants, and then we have 11. Yeah, out of these 60 participants, we have 11 who
Submissions.
opened the lab, and then did the submissions. And then we have 25 people who started the lab, but they didn't finish the submission.
And it's also interesting that all the participants come from oil and gas. Is that right?
Yeah,
Here?
yeah, it's yeah, that's very interesting. And I think we have two alumni, two previous winners from previous hackathon. I think John and Lee.
Okay. Well, let's start with the second place, where we have a tie. We have two second place, and we're going to start with John. He was also the first place hackathon winner last year, and it was very hard to decide in this case. He did also a very good job doing the presentation part of it. It was astounding work. Do you want to share your screen or talk about it, John, about this?
Yeah. I'll go ahead and share my screen.
Yeah, sure. Okay.
Let me just pull it up.
Oh, something happened.
There we go.
Okay, there we go. There it is.
So you can probably see right away it's bright and eye catching, which is kind of one of the goals. Just wanted to get the attention of the judges, which I think we did. So really, I started out with really kind of working within the files that were made available to us, and then that included everything within TIBCO Exchange. So there's a handful of Iron Python scripts. There's a handful of mapping styles and an overall CSS theme. So Neil Kanungo released an anomaly detection template about a year ago. And then some of that CSS I just kind of repurposed and changed slightly, and then added some new mesh gradients to just kind of make this a little bit more eye-catching. So really kind of started with his CSS theme and then just started modifying it. And then I found, if I zoom out on the map, I found a map box, and we use Mapbox a lot here at Intertel. So most of our visualization maps use our own custom map tiles. But I found this blue one, which is just a default map layer. So pretty much what we did is just created this layer, added a new Mapbox TMS layer, and then brought it in directly. So no modification. This is just pulling straight from the server. So this ties into the theme. And then I took the main blue color and then just changed the CSS properties. So if I go into each one of the HTMLs, you can kind of see the styling. And so just took that existing CSS, make modifications to it. And that's how we got left with this pretty theme. So like everybody mentioned, the hackathon this year was a little bit different than last year. So we were kind of left with an open-ended open-ended question, and the real cool thing about it was it's a new data set. I think every winner here is from oil and gas, and including myself. So food deserts was kind of a new topic to me, and so this was kind of a neat data set to play with and figure out how can we interrogate the data and get to some unique insights. So first bit of data was just going through the data canvas and loading essentially every single data set in here. So we pulled in all the available data sets and then just started relating them as needed. So most of these, just building in new data connections within the data canvas, having to freeze columns occasionally if there were calculated columns and we wanted to bring them in. And then so started building out the dashboard so once the data was in, interrogated the data through the data canvas a little bit and figured out what the columns were and where there was duplication across the data sets and just started pulling it in. Since a lot of the historical hackathons have been geospatially based, started with a map and kind of moved from there. So once the map was built, brought in the TMS layer, brought in the feature layers for essentially all the census tracts, and then started adding variables to the census tracts from the other data sets so we can then visualize. And then I really kind of wanted to build an interactive workflow. So being able to take map variables that are within the data sets and then being able to change it. So if I wanted to look at, median rent or, any of the subcomponents or any of the variables of interest, you can kind of see, receiving food stamps, percentage of households, total percent below poverty. So you can see how each one of these variables is dynamically changing. And you also notice that the bar chart on the left-hand side is also changing for this variable. So I gave a talk at this year's analytics forum on how to win the hackathon. And so I try to use a lot of the functionality that I discussed in that discussion. So your value access is controlled from a property, and you can see what these are just from looking at the expression. So I'm just taking that GeoVer property, which is tied to here in this text area, and then I'm just dynamically changing whatever variable I'm choosing within this. So if I'm looking at total percent below poverty, or I wanted to look at percentage of receiving food stamps, everything's dynamically updating. So you can kind of visually interrogate things as well as interrogate data on the bar chart. And then another neat thing is being able to look at a subset. So if I select the swath of Houston metropolitan, this will also then subset this data based on the markings. So the bar chart's controlled via markings to show all data when no data is selected, or just a subset of the data when I do have markings enabled. And then sometimes markings can be a little confusing, so just including a button to unmark selections. So the way I structured this was just, essentially I like putting all my document properties in tables, just a really clean way to format them, make sure they're all aligned, because I'm kind of a nerd when it comes to design. And then so building out those properties, and then also changing, themes. So I can look at, if I wanted to bring out a specific theme. So I'm a huge fan of the Veritas theme. It's great for color blindness. Because it's a uniform intensity of light throughout the entire color spectrum. So I have a variety of color themes, and I ended up using this red purple just because it kind of tied to one of the themes that was actually on the food deserts. The source data, their website, they had one of those themes. So I just essentially just mirrored this within my analysis. So you can go through, and if you wanted to change the theme, you can. So if there's any kind of colorblind issues or sensitivity issues, you can just change the color schemes. Again,
very well presented. Thank you. Are there any questions from the audience or from the people on stage that want to ask some questions to John? I want to comment on. So you use calculated columns, you use data functions, you use HTML and CSS to make it look pretty. Did you use any scripts or JavaScripts, maybe Iron Python, in your analysis?
Yeah, so these toggles, the toggle grocery store. So being able to add layers, not everybody is familiar with how to, configure the map layers. So being able to toggle the bus stops on and off, this is some Iron Python. Same thing with the grocery stores. I can toggle the grocery stores on and off, so I can see and visually interrogate, census tracts relative to grocery store availability or bus stop availability. So these are actually both controlled through some Iron Python. So if I look at the toggle bus, there's a map toggle bus. And again, you can kind of see that nomenclature and naming convention, I try to keep it all the same. So map color toggle, map toggle bus. And then this is essentially just an Iron Python script. These are available from TIBCO Exchange, but we're essentially just looping through the layers in the map chart, trying to find the layer that I've labeled bus stops, and then if it's enabled, true, and if not, false. So this is just looping and turning things on off with a Boolean with some Iron Python. And so each one of these, the grocery store is the same thing, just looking for that grocery store name. So it's a easy way to toggle things on and off. And then the map chart. This is just kind of coloring things as well, based on the geospatial variable color.
Very nice, outstanding work, John. Congratulations. Any questions from the audience or from the stage? Want to ask John before we move on? Unless you have other things to present, John. I see other two tabs.
Yeah, there's two other tabs, and we don't need to spend too much time on this, but really, and this is something I did last year in the hackathon as well. Trellising out the map chart so you can look at a specific vehicle, so you can look at map variables dynamically, and then we're just trellising out on a category. So I chose all the trellis categories to be demographics, so you can see Anglo, and then kind of look at the trellis buckets or bins of that variable mapped out, so you can see where certain demographics of populations live within Houston relative to grocery stores, and then other variables like what percentage of households don't have vehicles. So again, kind of self-explore the data set and being able to interrogate it effectively just through some drop downs.
Okay, perfect. All right, well, let's move on to our next participant, Braden. Braden, you want to share your screen? Where is it? Okay.
Yeah, hey everybody.
There we go.
Yeah, so when I use Spotfire, it's usually for data exploration. I love it as a tool for that. And Hackathon is definitely something a little bit different, where you have to very quickly orient yourself in a new data set, something you're unfamiliar with. It's also a way to kind of focus on storytelling with data, which is not something I do in my usual role. So it's really how do you tell data within Spotfire? Some people will just take screenshots of the visualizations and take it out of Spotfire to give a presentation. I kind of want to highlight what can you do within Spotfire. And then jumping into the Hackathon data set on the food deserts in Houston, did similar thing as John did. I joined all the data sets together in to the census tract data. Then I was kind of looking at regression and the column names, and just kind of figure out which story do I want to tell. And there are too many for me where do you focus on children or poverty, elderly, disability, or opportunity. So I try to do something a little bit different and focus on interactivity. So that takes me to this first tab, where I think a lot of what John did, I try to do. In fact, I borrowed his idea of using this Gantt chart widget as a legend. I actually really like that trick.
Yeah, that's a pretty cool trick.
And this first visualization, I kind of want to orient users to Houston. On my map layer, I used the dark roads theme to kind of highlight the roads. I think anyone familiar with Houston is familiar with the rings of highway that you see, that if you live in Houston, you're very familiar with the highways. But it kind of highlights the city center as well if you're less familiar with Houston. And then, I have some narrative here written in a text box and a very similar script, I think, to what John did, where, as you're reading, you can kind of trigger the map layers. My intention was to do this in JavaScript. As you've probably seen websites, as you scroll, the maps kind of interact. That was kind of what I was going for, but I didn't fully mature that idea. So here now the grocery stores pop up, and you kind of contrast that to the map layers, which are colored by poverty rate. So green you'd have a lower poverty rate. Red, you'd see a higher rate. And gray, we don't have data for. And then I used a data function to draw a 1 mile radius around every grocery store location. And I kind of use that as just, 1 mile is walkable for a lot of people, of course, not everyone. And that gives an idea of, if you don't have a car, which was a feature in one of the data sets, what would it take to get to a grocery store? And then the final step would be to make that data kind of disappear. And these are the areas where, you're greater than a mile away from any grocery store location. So when you kind of contrast with your options, that kind of gets you closer to the definition of a food desert. It's hard to see in this exact view, but my intention was, to show like fewer grocery stores go with increased poverty rate. And then the second tab, which is really want to go for something different. I think this is the tab I'm most proud of. I did a couple different things here. Goes back to there were maybe too many variables in the data set, so like too many stories to tell. So I tried to just make the data more relatable, more personal. So if you look at this sheet, you have a story where, it gives you almost a character. So you are a, DN, you're 13 years old, you're a Black child living with extended family, living, in Houston. It gives you your household income and your family has no car. So I'll get into how that was made, but then it shows you that you're from where you live, you're thankfully less than a mile away from the nearest grocery store, this Walmart location, and you're over 2 miles to the nearest bus stop location. So, if this family doesn't have a car, you're either looking at where you are exactly in this neighborhood, or you need to venture out and kind of get connected to the public transportation network. And then when you roll this dice, you get a new character, and hopefully it all updates. So now, you're Lana, 8 years old. You're in a different part of Houston, and your medium income is now 53,000. And again, unlucky for you, again, your family doesn't have access to a car. But now you're over a mile to the grocery store, but you're closer to the nearest bus stop. So I kind of want to make this, not make it a game, but like, make it more interactive where, when you're looking at all of Houston, it's hard to kind of understand like, okay, what does a mile mean? What are bus stops? And I want people actually like kind of pause on this tab and think it through. So now I'm going to kind of break down the components that I'm doing here. So this is a visualization mod. It's the text card mod. It kind of let me take a name and the location and actually display this sentence about a person here pretty easily. And even taking a step back, making this like person level data set, I kind of had to make a few assumptions where I started with a data set that was just 6,000 of the most common names, found that online. And then I use a Spotfire custom expression to kind of do a random lat long between like the Houston min and max lat longs. So, I kind of had fake coordinates, and I did an outer join on that to kind of make a grid of locations. And then when you roll this dice, I use an IronPython script that'll randomly filter one row at a time. So if we click it again, it's kind of filtering to one random row ID. And then I was able to join that coordinate data to our census tracts, and that's how I was able to kind of get the medium income, some of the demographic information, whether they have a car or not. And then these two visualizations are KPI cards, and they're just kind of coloring by whether you're greater to or less than a mile to a grocery store or a bus stop. So you're doing two nearest neighbor functions to get that information. And then just a quick up, I did want to do some classic, beautiful Spotfire visualizations. So I, want to show off those. And then the last one is kind of a data exploration tool, similar to what John did, but not as feature rich. But again, like his idea of the interactive legend.
Yeah, that's pretty cool. I really like the way the storytelling you made, especially at the beginning where you have these buttons where you can start going, step 1, step 2, and then you start highlighting those areas and the description and the text area that will guide you through how it works. And then the second tab, when you have that dice that definitely engage the audience for them to want to click on the dice and just have a real world example of anyone that it's dealing with a food store nearby. Atir, do you have any highlights? Did you think about this?
I like the the idea of rolling the dice and then imagine a different life. It's impressive, and then it's interesting that you solved most of it without using a data function, only like in the part of the random sampling. I'm wondering, how did you? I'm not sure if you mentioned that, but how did you render the routing from the person to the bus stop to? Did you use a data function for that?
Yeah, I used the nearest neighbor data function you can find on the TIPCO community page.
Okay.
So I used it twice, one for the grocery store data set, one for the bus stop data set. And the lines and the points come from the output of that data function. And I use a data function to get the points of my fake people, my coordinates, to the census tract information. So the points and polygon data function I also used.
Did you have any issues with coordinates conversion from one system to other system? Did you need that? I think, I recall that
I sure
we
did.
had issues with that. Yeah. Okay.
Yeah. I ended up spending, making this fake data set is probably where I spent the most amount of time. There was a point in the day I almost gave up and went, it's not worth it at the time. The coordinate conversion, it's in the documentation. I just didn't read closely enough. The points and your polygons need to be in the same coordinates or it won't work.
Excellent. So we have a question from the audience. Let me pull that up. And does the original table need to be duplicated to exist unmodified, or what's the most efficient way to handle such scenario?
I don't think I duplicated any. I'm not sure if I fully understand the question, but I don't think I duplicated any data sources. I joined to the census tracts. I think I heard John do the same. I guess I did a different kind of join to that demographics data. That's a duplication of data, but that's a new kind of data source.
Okay.
Anyone else has anything to add there?
All right.
Yeah. I was going to say, within the data sets, when you're working within the data canvas, the nice thing about those joins and all the machinations that you're doing within the data canvas, you're still left with that raw source table on the left-hand side. So if you ever need to remove those, joins or any other added columns or rows, you can do that pretty easily. So you generally don't need to duplicate a data set.
Yes, and the original data set is not going to be affected if you make changes or anything, because the data is copied into memory, and then the source data set is not going to be modified. Any particular challenges that you faced, Brendan, during the development of this dashboard?
Oh, we touched on probably the biggest one that points to polygon script. I did end up getting that working.
CSR
And then time, John's really good about putting out like clean dashboards, and there's a few things in here that just aren't as like tidy or as like if I was presenting this to a client, I definitely would want to clean it up a little bit further.
Did you use all your lab time?
Yeah.
Was it enough? 8 hours? Do you think like we needed to make it more?
Yeah, I think that's a good amount of time.
Okay. Mm-hmm.
Yeah, I don't remember if it was last year. Maybe been shorter. I think I actually ran out of time last year and didn't submit.
Mm-hmm.
Okay, excellent. Let's move on to the first place. The first place was Lee Grant, Luisa Porras, and Tomas Moore with the food and desserts. So
Cool.
let me know when ready so I can pull your screen. You're sharing the
Yeah.
screen on the page.
I think it's pulled up. Yeah, and I'll just kind of flip through in this rather than.
Oh yeah, it is. Okay, good.
But yeah, I'll kind of briefly go through the PowerPoint submission, which I guess was a little bit new and unique for this year. In fact, we kind of misread the submission requirements, and it was pretty late in the game when we realized we actually needed one. So good thing we did finally get that read. So I'll kind of go through here. You'll see we kind of had this theme that kind of worked its way through the PowerPoint and also the Spotfire project. So first and foremost, kind of talked about it here, but again, new this year, there's the option to submit as a team. So that's what we elected to do. So I'd like to just give a shout out to Thomas and Louisa, who also present a little bit today, just for their involvement. And it's definitely a good team effort. I think we had probably enough ideas generated for about 3 weeks of work. So we had to kind of distill that down into the ones that we thought were the most useful to try to get our story across. Yeah, so obviously it's a super complex problem. We're definitely not experts in it. Echoing kind of Brendan's comment there was so many nuanced bits of information in the data sets. It was hard to kind of really focus in on a lot of them. So we tried to work, again, with the theme of kind of interactivity and allow the user really to kind of investigate themselves. So the general workflow, quite a bit of time this year spent on data engineering. We'll talk a bit more about it, but there's lots of tables. There's lots of spatial operations that had to happen. So definitely not, say, like super kind of beginner. It definitely required a little bit of know-how and a comfort level working in data canvas and using data functions. We kind of honed in on 3 key factors: proximity to grocery stores, accessibility to transportation, so whether or not somebody had a vehicle or were close enough to transit to use that, and then some economic factors like income and poverty rates. Kind of the 2 ways that we tried to pull these things together in more of a actionable way were this dynamic food desert risk tool, and then kind of this what if analysis around if you dropped a grocery store somewhere, what kind of impact would it have. I won't talk too much here. We kind of hit on some of it. So there were some potential gotchas in some of the coordinate system stuff. So as mentioned, there's a few different ones that you kind of had to work seamlessly between. So we used a data function to transform them all into one similar data set. And even just like the fact that these are coordinate systems that we're not typically familiar with and used to using, being up in Canada. I mean, it's just one more thing to keep in mind and make sure you have everything straight. We used a couple of different distance functions. So we kind of use this distance matrix function, which Thomas had noted somewhere on the exchange. And then we also did some kind of spatial intersection work as well. I won't talk about these specifically, but the PowerPoint kind of walks through each of really the tabs as it's laid out, which you'll see when Thomas goes through the project itself. And then here we're just kind of speaking to some of the conclusions. Yeah, this is kind of working through the specific user interactivity tools, kind of going into that. You can see we tried to be consistent with the color scheme throughout both. Going all the way down to kind of the summary. So I think the documentation and the intro for the hackathon itself said roughly 500,000 residents. Based on our investigation, and if, depending how you configure some of these things in the interactive piece, we said potentially as high as 1.5 million. So it's definitely a sizable problem, and I think worth the time spent this year in the hackathon. I guess one last comment before switching over to Thomas. You could probably swap his screen over, but pretty cool to see the contrast between the other submissions as well. Definitely some different focuses and some pretty cool stuff.
Okay, we have a question from the audience again. It says the key factors: distance from grocery store, etc., took like they were outlining ahead of time. Is that right? Will the approach differ if entering this investigation without that upfront knowledge?
Yeah, I think between what was provided from the hackathon intro material, and then, if you look on like Wikipedia, it definitely suggests that that's a pretty strong indicator. So it's definitely one we focused on pretty quickly, but I think you could probably, it's like a pretty, especially even if you just look at the map, right? It's pretty apparent pretty quickly that there's a concentration of grocery stores close to the core of Houston, and then it really kind of stops after a certain point, which is interesting because also looking at the population, it kind of is the opposite. There's actually a pretty strong population kind of in the suburban areas as well. So I think we probably would have got there, but having it available to us, we definitely took that and ran with it.
Okay, thank you. Any other questions? Maybe?
Yeah, do you want to flip over to Thomas so you can do a bit of a demo? And
Sure.
we can continue answering the questions for sure.
Yeah, of course. I have a question. Like, how were you organized to, like, it's a team, 3 people who was working on this project. How did some of them were on the back end or front end, or you put a plan together? Did you work on separate instances and then you merge them, or how did that came together?
Yeah, a little bit of all of those things. So when we kicked off, we kind of met together in a office or a meeting room, and we kind of started just bringing in the different data sets one by one, combining them, kind of seeing what was there and generating ideas. So that was maybe a nice part of working as a team, is that brainstorming ability. From there, we kind of decided where we wanted to focus, tried as best we could to kind of split some of the stuff. And then I'd say like Louisa and Thomas were responsible for more of the more detailed analytics. And then I was kind of trying to pull it back together and incorporate it into one kind of instance that we'd ultimately submit. And that's kind of how we worked through it.
And then you said you started brainstorming about the problem before the hackathon. How many days you started, let's say, looking into that?
No, sorry. That was just the morning of. So once we kind of had the virtual environments and we could kind of start looking at all the data sets specifically, that's kind of when we together we did a bit of data exploration and started brainstorming.
Okay, and Atir, would you like to mention what was the judging criteria for the hackathon?
Yeah, let me
pull that up. You want me to share your screen, or?
I can share it here. Yeah. So we have 4 categories: innovation and creativity, visual storytelling, interactivity, and then like how impactful is your submission. The total of judges, I think we have around 10 from different teams, and then we also have an industry expert whom we sent the final submission to them, and then they provided feedback, and I think I shared the feedback with the winners. So and then the scale was from 0 to 10 to all these categories. We don't have like anything, let's say specific or deterministic. We're looking for some creative ideas, and I think all the winning submissions, they have this part of it. They're all creative. Some of them are really visually attractive, and then some of them they worked on, let's say, more on the analytic side. But basically, yeah, we gave like the same weight for all the 4 categories.
Yes, that was very, very nice, and it was a very nice way to solve all these problems with this particular submission. And the visual storytelling was also very, very outstanding. And one of the things that caught my eye was that you didn't use any script or IronPython script or anything, and still was looking very nice, your presentation. So let's go back to it and let Thomas continue talking about it.
All right, thanks. Yeah, so I guess we just have a little landing tab here to introduce the project. And then our first tab kind of goes over some of the data engineering and how we joined everything. Lee and others have touched on this quite a bit already. I just want to echo too that there was a decent amount of time trying to get the coordinate systems online from all the data, just so we could do some of the more different spatial analytics functions. So I'll kind of more dive into the actual dashboard. So kind of the first little bit, as we even went through the data, a lot of it was just exploring the data sets, what we had, what could we join together, what was our coverage, and that kind of thing. And this is kind of a formal visualization or method of how we went through that. So we kind of have the map set up, and then wanted to be able to set it up in a way so people could maybe explore all the different columns. As it was mentioned, there's quite a few to look at and see maybe how that would how that might affect someone's analysis or interpretation. So we kind of have a drop-down menu here that looks at a couple different things. So for example, I have brought up just visually showing the distance between the tract and the nearest grocery, where we have more grocery stores where the black dots are. They obviously are those tracks are a lot closer to grocery stores, and maybe wouldn't be at first glance considered a food desert. You can obviously see more of the suburbs in the outside area quickly showing as having a lot farther distance to a nearest grocery store. And then kind of can click through these visualizations to highlight certain parts of the map and kind of see where maybe some of these areas that have a lot farther distance where they are. And then this kind of just highlights the top 20 of based on that metric. So kind of I wanted to set this up in a quick, easy way to slice through some of the columns, just using some document properties to be able to change the different visualizations on the map all at the same time. I think we're good there. And then, so moving on to the grocery store analysis. So kind of as just discussed, a big hypothesis of ours is that a food desert would be kind of dependent on how close a grocery store was there or not. So we first behind the scenes used some data functions to calculate using the distance matrix data function to calculate the distance between the tracks and the nearest grocery store. And then also kind of use a points and polygon function to determine, which tracks actually have a grocery store within their area. So again, this is all interactive. So, if we wanted to find all the tracks that didn't have any grocery stores in them, and also were maybe farther away than 1,500 meters, which is roughly a mile. It kind of quickly shows you a grocery store or options, and so it in their own.
Sounds like he's
ideas
breaking
of
up.
what. Another impact that we thought might contribute to a food desert is maybe someone's poverty level, with someone's income level. And so this is kind of a nice way to maybe highlight some of those tracks. I guess one thing is we first looked at median household income per household, and very quickly saw that actually a lot of the tracks we didn't have data for, which is highlighted by all these gray areas. So we wanted to maybe find another metric that was similar, but had better data coverage across all of Houston. So that's where we looked at this below poverty percentage. And you kind of see we have a pretty good relationship there between the median household income and the poverty level. So we decided to kind of use that as more of a proxy for determining the poverty level of a tract, just use that as a way to identify what if there might be a possible food desert. I think a nice thing we did in this visualization too, I think, was just highlighting maybe some of the anomalies using these stars, where there seemed to kind of buck the general trend. So for example, this tract up here just highlights that it has a pretty high household income, but still has a relatively higher percentage of their population below the poverty line. So maybe just shows that in this certain tract, there's a really wide disparity between the high income and the low income earners, and it might be worth further investigation. For good there, we might move on to some analysis we did using the bus stop data, and I'll actually let Louisa speak to this one.
Thank you, Thomas. Yeah, so in the bus accessibility section, the idea here was to determine which areas had not access to public transportation or also not access to a vehicle, and also which areas didn't have a grocery store within a walking distance. So to be able to perform this, we have to integrate multiple data sets. But as Thomas mentioned earlier, we had to put everything in the same coordinate system. Once we got all the X and Y in meters, we were able to calculate the distances between the center of a track to a nearest bus stop, and also the distance between a grocery store and a bus stop. And for this, we use two data functions in Python. And once we got all the distances, we start kind of like doing the visualizations. So looking at the dashboard, starting from the left side, we have a histogram that kind of shows which tracks are far away from the grocery stores. So if you highlight the top tracks, you will see on the map which areas doesn't have a bus stop nearby. Also, if you look at the map, this map in blue color is showing the bus routes, and the yellow color, like the tracks are colored by the distance from a track to a bus stop. So the darker colors, the darker yellow colors show areas where we don't have a bus stop nearby. And also in black colors, the dots are the grocery stores nearby. So a good way to visualize, since our focus was to identify areas that didn't have access to transport or didn't have a grocery store nearby, we created these cross plots that shows essentially on the x-axis shows kind of like the distance from a track to a bus stop, and on the y-axis the distance to a grocery store. And we color the points also by the vehicle, percent vehicle, no vehicle access. And we put a reference line at 2,000 meters, because essentially we wanted to focus on areas where they didn't have a grocery store within a walking distance. So our focus would be kind of like the areas where there is no bus stops and also no grocery stores within 2,000 meters. And yeah, so I think this is kind of like a good way to integrate all the data and visualize which areas have a lack of transportation, but also doesn't have access to a grocery store within a walking distance.
Excellent. Okay, so I have a question, Luisa. How did you manage to make all the data sets to be on the same coordinate system, and how did you figure out that you needed to do that?
Yeah, so because I guess the census tracts were in lat and long, and another one was kind of like in X and Y meters. So then we had to kind of like put everything in meters to be able to calculate distances in meters. And for doing that, I guess I initially did everything in Python, but then we also found a data function that has kind of like points in polygons, and we used that one too. But yeah, it was just mostly for the units, right? Lat and long, and then the X and Y.
Yeah, I think we realized we needed to do it when we had an error pop up, and luckily, I know I've been burned by this many times before, so didn't spend too much time, I guess, knowing what the problem was. We were able to pretty quickly identify what it was, and then we just had to go about fixing it. Luckily, we had a data function we use internally to perform the coordinate transformations, so there's a bit of a leg up. Thomas, do you want to go through the last couple? These are really the most probably interesting. These are kind of like all the steps we took to kind of know how to make some useful things on kind of the last two tabs.
Okay.
I think he's frozen. I can hear him talking.
Oh yeah.
Yeah. So
There we go.
There he is.
can you?
It's a little bit choppy, Thomas.
Out a bit again. Sorry about. So really, these last or the second last are the food deserts, and obviously, as was mentioned, we want this to be someone who is an expert. What tracks will pop up, and maybe some of the metrics behind it. So on the left-hand side are kind of some different things that people can input. So it's nearest grocery store, if there's a grocery store in the tract or not, poverty rate, vehicle accessibility, and then also distance to a bus stop. These are all kind of user inputted, and they can play around with them to see which tracks kind of pop up, and really identify what where the food deserts are based on a certain definition. So here we go. If we just do the slider, kind of can set our criteria, kind of see which tracks pop up, and then we get some interesting metrics based on how big is the population, what their nearest distance to the grocery store is. So kind of interesting enough, if we just use this definition, on average, most of the people in these neighborhoods would have to walk about 4 kilometers or over 2 miles to get to the nearest grocery store. So a pretty far distance. And so we liked having this as an interactive way for people. And then once people were comfortable with their definition, we want to maybe give users an ability to play a what if scenario, or going from the idea that hopefully adding a store might help store. So that's where
Seems like a bad internet connection.
that or airdrop a grocery store, as we call it, anywhere. And so, for example, it looks like this is a pretty concentrated area here that we've defined as a food desert. So and then run a data function that takes that point and then kind of looks at which tracks would be in a 2,500 meter buffer. And then hopefully it expected. I'm not sure what's going on.
Yeah, maybe too many resources running on your machine, because your video is kind of choppy sometimes and your audio goes on and off. But we were able to get the idea across.
Yeah, usually it was fine before. But...
Yeah, sorry, it's chopping up a bit. I can hear him through the wall. Yeah, so basically this was just supposed to be like, you could kind of do a bit of a what if. So you see a bunch of potential food desert area. You could drop a pin on the map, and then it would basically give you a bit of a quick and dirty assessment of how many people could be impacted by the addition of a grocery store. Obviously, like, there's tons of factors that would have to be included before, a company would go and do that. But, at least you could kind of get that conversation started and see the potential impact for, making a change based on what you're seeing within the dashboard.
So are you recalculating the, let's say, the distance from the new dropped grocery store to the areas after someone clicks the preview effect of a new store?
Yeah, exactly. Yeah. So we'd kind of be calculating distance from that hypothetical store to surrounding tracks. And then we also, in the KPI tiles, kind of summarize of the tracks that are intersected, which of those are specifically considered food desert and then which are not. Because obviously, like, you could see, some benefit from a track that maybe is not considered a food desert, but really the one we're trying to focus on is the others, which are, at risk for being a food desert.
Yeah, I like the idea. I mean, this can also be a good tool for decision makers if they want to evaluate, let's say, a proposed grocery store location very quickly, for example, as you said.
For sure, yeah.
Jose, you are on mute.
Thank you. Yes, we have some. We're almost done with the time. We have a few minutes left. We have a couple of questions here. I'm going to start with Juan Carlos. He's asking if the recording this section is going to be recorded. Yes, we have a record. It's going to be recorded, and we have a couple more questions. Let's see. There is a question. I don't know if we'll have time to that, but how is a pin drop mechanism achieved in a visual? Is this something that's native to all map type charts in Spotfire?
Yeah, I can quickly hit it. So the way that we did it, and it's a pretty quick way of getting there. There's more maybe like intuitive or seamless ways you could do it, but any map in Spotfire, you right click, there's a copy coordinates option. So we harnessed that. So we just copied it and then would paste it within a doc prop. So kind of using fairly out of the box functionality, you can kind of get to that quote unquote pin drop.
Okay.
We have
there
a
is
question
also,
from Ahmad.
Yeah, last one question from Ahmad. Is the distance based on driving, walking, or as crowd flies?
Yeah. Good question for sure. All the stuff we did were kind of just like straight line distances. And in a lot of cases, we were using like the center of the polygon as well, which all of those things for sure you could refine. Like there's, we had tons of ideas. Like I said, you could do like route optimization and that kind of concept to get probably more accurate numbers. But obviously within the time frame, we were trying to do the best we could. So we were using mostly straight line and then from center point to center point in most cases. I don't know if anyone else like did something other than that. It's definitely something we would have loved to do.
Awesome. Well, thank you everyone for participating. Hope we'll see you on the next TIBCO Analytics Forum next year. And thank you everyone. And again, congratulations. Great work, everyone. So before I wrap up, I just want to give you a quick reminder that if you have any suggestions on how to improve the Spotfire or ideas, there is a learning ideas or the typical ideas portal or Spotfire portal. Then that's the QRC code where you can submit your addition. And there's a new section that I encourage you everyone to look at, and is the learning. So the learning is for anyone that is interested in knowing more, like a white paper or quick tip videos, or maybe a Dr. Spotfire session that you like us to cover. That's a place to put it on in ideas.tipco.com, and that will be the submission that we will be required. Thank you, everyone, and see you next time.
Thanks, everyone, for listening again.
Bye.
Thanks.
Yep. Thanks for having us.
All right.